Well, well, well. Aren't we progressing? Yeah, now we come to volume and cube root. We finished with square root. Now cube root. Now look at this box, okay? Now this box, okay? This occupies vertical space, and see, this spot is horizontal. We call these are horizontal, okay? It's horizontal space and also vertical space, okay? In the tile that we considered previously, it was very flat, so no vertical space. Yeah. So everything is self-explanatory. See, a cube becomes a cube. Think of the snakes and ladders dice. It's a cube. I hope so. So uh, a cube has all six faces as squares. Okay, there are six faces. Okay, and all the faces are squares, and all the squares are identical. Like each square is side 1, 1, etc. Okay, out of the cube, six square faces, all identical, 12 edges. Now the cube occupies space, see, horizontal and vertical. Now, so again, mathematicians were stumped. They said, well, how to measure this? Now, then the concept of volume introduced. The cube is said to occupy a volume. Now, this becomes the unit for the measurement of volume, which is 1 cubic centimeter, okay? That is 1 into 1 into 1. If you want to see this may not be a cube, okay, leave it. Yeah, one side into the other side into the other side. Okay, yeah, so multiply all those sides, you get the volume in cubic centimeters or cubic meters. If this is meters, then the volume becomes cubic meters. Yeah, the concept of volume is introduced in the cube. Now, a cube is said to occupy 1 cubic centimeter. This cube, okay, this cube, and is taken as the unit of volume measurement. Yes. Now, you know something, if you put 1,000 of these together, 1,000, okay, you get what is the volume, the space occupied by it horizontally and vertically is called a liter. A liter is 1,000 cubic centimeters, okay. So these are all units. So similarly, 1 meter cube, 1 millimeter cube. Now, here, like in squares, the side of the square was the square root of the area. Here, the side of the cube is the cube root of the volume, as simple as that, okay. Right. Look at this, unit of volume measurement. Same thing here. Now here, this. If you took 8 of these, this is what you would get. And assemble them. This doesn't look like a cube. Figure is not accurate. These are right angles. Okay. So there'll be 8 such cubes. So the volume of this is 8 into the volume occupied by 1 cube. Okay. Which is 8. Incidentally, this cube B is like this. Dude. So the volume will be, if you want, be this and this. Okay. Cubic centimeters. All the sides, length, breadth, whatever you want, what do you call it? These are the horizontal dimensions. But all these are equal. Okay. Now the cube root concept. We're given the concept. Okay. I explained all this already. The side is the cube root of the volume. So 2 is the cube root of 8. Learn how to again exchange, okay? If this you want to knock off this umbrella comes to this side as 3. Don't confuse with the square roots, okay? So you knock off this umbrella, so this becomes 2 cubes. So learn how to go back and forth. This is very important. Demo problem 1. I won't explain much. It's the same as square root principle, but here you take it in groups of 3. 3 groups, okay? For every these 3 you take 1, 3. For all these 2's you take 1, 2. So 6, so 6 is the cube root of 216. Demo 2, 512. I think it's self-explanatory. Yeah. I have an important result. See, cube root of minus x. That means if you take a negative quantity, the cube root will be negative. Now compare with square roots. A square root of a negative quantity does not exist, but here you be careful, it can't exist. This is the proof. See, minus 2 into minus 2 gives you minus 8, which is minus 2 cubed. So minus 2 is the cube root of minus 8. Yeah, that's an important result. Don't forget that result, okay? Yeah, so that's the end of this part.